Okay, math analysis. This is the chapter 8 and 9 review. This is the second part. I'm going to do problems 15, 16, and 18. First one, problem 15. We have to find this. This is a cosine subtraction identity. So what I'm going to first do is just break this apart into its pieces. So cosine pi over 6 minus x. Remember, cosine flips the sign, and and cosine doubles. So it's going to look like cosine first thing, which is pi over 6, cosine second thing, which is x, cosine flips the sign, plus sine first thing, pi over 6, sine second thing, x. Okay, so I use the cosine subtraction identity. Remember, please, 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 we've harped on this. Do not think that you just distribute the cosine through or something like that. That is not correct. Not even close. Okay, so looking at the expanded out form, basically 3 out of the 4 things we have or can get already without having to do any more any new work. We should know what the cosine of pi over 6 is. We can draw it out, we can figure it out. Likewise, we should know what the sine of pi over 6 is. So I'm going to go ahead and do that now. Get that out of the way. Because again, pi over 6, we should know that angle. Pi over 6 is a 30 degree, 1/6. So a 30 degree reference, it's a 30. There you go. That's not very good, but 30. That looks more like a 90. I don't like that. Well, we're going to get rid of it. Okay, I'll try that again. When in doubt, draw it bigger. Okay, so my reference angle is 30. The opposite of a 30, again, is 1/2. The adjacent is √3/2. This should be second nature to us. So the sine of pi over 6 is 1/2, so I can plug in 1/2 there. Cosine of pi over 6 is √3/2. Okay. Now, I've got 2 pieces that I have not solved for yet. There we go. But I do know the cosine of x. It tells me. It explicitly states that the cosine of x is -1/4. So I can replace cosine of x with -1/4. So I'll be multiplying those together, and I'll deal with that in a little bit. The only thing that I don't know, and this is how these usually work if you've worked through a few of these, is that I got everything except for one. I've got 3 out of 4 pieces. That's where I've got to look into all the information that it's given me in the problem. First big thing that it gave me was, I think it froze up. Hold on just a second. There we go. This information, remember, this is basically just telling me what quadrant I'm in. Between my angle, my x angle, is between pi over 2 and pi. Well, there's pi over 2. There's pi. So I'm somewhere in the second quadrant. So you want to just draw a triangle in the second quadrant. It doesn't really matter if you try to draw it as a 30, a 45, or 60, because it's none of those. It's just some triangle, so just draw whatever you want. All I know about the triangle is that the cosine is 1/4. So again, think of cosine back to what we've done since algebra. Cosine is adjacent hypotenuse. So think of it not like it's a unit circle problem, but the adjacent is 1, the hypotenuse is 4. So from whatever this angle is, the adjacent is 1, the hypotenuse is 4. I need the sine of that. Well, the sine would simply be the opposite over hypotenuse. So how do I get that? Well, I just use Pythagorean theorem. Try that again. So it'd just be 1 squared plus b squared or something equals 4 squared. So you'll end up with b squared equals 15. So this length is the square root of 15. Now you gotta remember, is sine positive or negative in the second quadrant? All students, it's positive, so it's positive opposite hypotenuse. So this is root 15 over 4. So again, I was able to find these because I've done those forever. The problem gave me what the cosine was. Again, it's got to give me something. It gave me what the cosine of x was. I had to build the triangle in the correct quadrant to get the sine. Now it's just a matter of multiplying. So now this will become negative root 3 over 8 plus this will be root 15 over 8. Now, all you can really do from there, since there is a common denominator, you could put both of these in the numerator and just make it one fraction. Or you could have root 15 minus root 3, doesn't matter. All over 8. Nothing else I can really do to it. So there's the solution to that. Pretty non-standard number there, but it does work. Okay, 2 more to go. Next one I'm going to do is number 16. There's actually 3 parts. I'm using double angles here. Remember, this doesn't just mean I find the answer and double it or something. It's a double angle identity. So to double the angle, 2 sin cos is sine. So I've got to do, for the sine of 2x, yes, this stuff will all be in red. For the sine of 2x, it is 2 sine x cosine x. That is the double angle identity. I proved it in class. Okay, well again, let's look at the info we were given. All we were told is what the cosine equals. And again, when you see this information, think, oh, they want me to draw a triangle. 3 pi over 2 and 2 pi, if my angle is between 3 pi over 2 and 2 pi, my angle, that means that I've got to be in the 4th quadrant. So again, just draw some right triangle in the 4th quadrant. Doesn't matter what it looks like. Again, it's giving you some information. The cosine is 7/9. Pen keeps freezing up. Here we go. 7/9. So again, from the angle, the adjacent is 7. The hypotenuse is 9. And again, by the way, according to all students take calculus, the cosine should be positive, and yeah, it is. So that does coincide with this information that I'm in this quadrant. I got to figure out the missing side. If you've noticed, every time we draw the triangle, we need all the sides. So I have to use Pythagorean theorem again. 7 squared plus b squared equals 9 squared. So this would be 49 subtracted from 81. So 81 minus 49. And that is, I believe, 32. Yes. So b squared equals 32. So now I would just square root. I'm going to go ahead and break this down right now because I know that it's not going to go away later anyway. So this would be 2 and 16. And if you remember, a shortcut, you don't have to get prime numbers. As long as you get a pair, you can extract that. So root 32 broke into 4 root 2. What did I just find? I found the missing side length. 4 root 2. Now, since I've got the triangle drawn, I can find anything I want out of this because I've got the opposite, the adjacent, and the hypotenuse. So I can get every piece of information I want. Alright, so back to the sine of 2x. It's 2 times the sine. The sine from here would be opposite hypotenuse. And now I know you're thinking this. Hey, wait, sine's negative in that quadrant. Yep, put it in there. The cosine is adjacent hypotenuse. Also, they gave us it already. So the cosine is 7/9. And just multiply it all together. So really, again, that's 2 over 1. So 2 times 4 times 7, I believe that is 56. So I'm going to have negative 56 root 2. So I still got that root 2 in there. All over 9 times 9, 81. Not intuitively obvious, but that is the sine of 2x. Okay. Now to the cosine of 2x. 2 double the angle, 2 sin cos is sine. For cosine, just use this one, both squared of cos less sine. Cos squared of x minus sine squared of x. Okay, so what is the cosine? Well, it already gave me that, 7/9 squared. Minus, what's the sine? Well, I've already found the sine. I found it over here. So it's going to be minus negative 4 root 2 over 9 squared. All right, looks pretty nasty, but we can do this. We all took algebra 2. So when I square this, I square both. I drop it in like it's hot. So this would be 49 over 81. The negative squared is going to become positive, but there's still a negative out in front, so it's going to stay negative. Remember, I really just square both of these. So that's going to be 16 times 2. Root 2 squared is 2. So 16 times 2 would be 32. Square the bottom, 81. Common denominator, so I can subtract them, and I get, let's see, that would be, I believe, 17 over 81. And there's the cosine of 2x. Okay, now for the tangent, since we've already done the sine and cosine, and we mentioned this of 2x, we mentioned this in class, yes, I could do that over that, flip this fraction, but on the test there's going to be a problem where it just wants the tangent. So rather than showing you how to do it this way, because that would mean on the problem on the test you'd have to actually find the sine, then the cosine, I'm just going to go ahead and use the tangent double angle formula. This one you don't have to have memorized, I'll have it on the board, but the tangent, excuse me, the tangent double angle formula is 2 tan x over 1 minus tan squared of x. Okay. I haven't found the tangent yet, but tangent is just opposite over adjacent, so 4 root 2 over 7. It will be negative because only cosine is positive here, so this will be 2 times negative 4 root 2 over 7. That's the tangent of x, opposite over adjacent. All over 1 minus, in parentheses, this would be negative 4 root 2 over 7 squared. Tangent squared. Alright, so I've got a lot of cleaning up to do here, but this will become negative 8 root 2 over 7. Okay, down here, let me do some side work here. So this will be, well, I know I'm going to have a denominator of 49 here, so I know this is 49 over 49. So I'm just getting some common denominators here. Okay, so this, just down here, is going to become that minus, again, squaring the negative, but there's still a minus out in front. So this again becomes 16 times 2, so 32, over 49. Oh, froze up again, hold on. Let it think about it. Oh, there it goes. Okay. So this denominator, remember this was all the numerator, over the denominator of, if I minus that, there's that 17 over 49. That's this denominator, the 17 over 49. Multiplied by the reciprocal, times by 49 over 17. You can reduce that to 7. And now multiplying across the top, so I moved that up, we'll get rid of that. Negative 8 times 7, negative 56 root 2. All over 1 times 17 is 17. Not very pretty answers, but we can get there. Again, if you look, if we did that times the reciprocal of that, we would obviously get that. So that's really 3 problems in one. You're not going to have a problem on the test if you do all 3, but at some point you'll probably have to do a sine of 2x, a cosine of 2x, and a tangent, just in different problems. But again, big thing is when you see that, draw the triangle, find all the missing pieces, or the missing piece, excuse me. And then you can find any trig you want, sine, cosine, or tangent. Okay, last one I'm going to do is actually a faster one. Solve this on the interval. We have a sine of 2x. And if you watch the other video, I said sometimes it's not good to convert that into its identity. It actually would be okay on this one to do it. So I would usually try that first, see if it's going to come out okay. So the sine of 2x, 2 double the angle, 2 sin cos is sine. So that breaks into 2 sine cosine. I'm going to go ahead and add this over, the negative cosine, to the same side. So plus cosine equals 0. Now looking at this, I do have a common factor of cosine. So I can factor that out. So cosine x. If I factor out cosine, I have 2 sine x plus 1, if I factored out cosine, equals 0. Now it goes back to the same kind of problems we've done several times. I want the cosine to equal 0. That'll zero everything out. Or I want the sine to equal negative 1/2. Now I just spin around the unit circle, just as 0 to 2 pi, and I figure out where the heck does the cosine equal 0. Well, that happens right here. That's the point 0, 1, and it happens down here at point 0, negative 1. Remember, it goes cos sine. So that is pi over 2. That is 3 pi over 2. Okay, so those are the two answers that solve that one. Now, where does the sine equal negative 1/2? We actually had this on the other video, but I'll do it again. Where does the sine equal negative? Well, sine's negative down here. And this one, what angle gives me 1/2 for the opposite? Because remember, sine is opposite. It is, again, a 30-degree reference there, or a 30-degree reference there. And once it unfreezes again, there we go. There we go. Then the final question is, what is that angle in radians? That is 7 pi over 6. And what is that angle in radians? That is 11 pi over 6. Ooh, that looks terrible. Let's make that look prettier. 7 pi over 6, or 11 pi over 6. Again, that solves this part. So there are all my solutions that can make this true. Hopefully this all helps. The test is, again, not easy. This is definitely one of the toughest tests. But I think going through this review sheet should put you in good shape for the test.